Let's go ahead and do this binomial expansion for 1 plus x to the negative 1/4. We notice that p is equal to negative 1/4 there. And so f can be written in the binomial form negative 1/4 choose 0 plus negative 1/4 choose 1 multiplied by x plus negative 1/4 choose 2 multiplied by x squared. And we'll go one more non-zero term, negative 1/4 choose 3 multiplied by x cubed plus etc. The evaluation of the first two binomial coefficients is pretty easy. This one is always 1. This one is always equal to p. And now we have to figure out the next two. So let's come off to the side and do that. Negative 1/4 choose 2. We will take negative 1/4. We will subtract 1 from it. And then we will divide by 2 factorial, which is 2. This is going to give us positive 5 divided by 32 as our coefficient. And then we'll do negative 1/4 choose 3. So that will be negative 1/4. Let's kind of get a little more space up there. Negative 1/4 multiplied by negative 5/4 multiplied by negative 9/4, all divided by 3 factorial, which is 6. So that is going to be a negative number. We are going to have 45 in the numerator divided by 4 times 4 times 4, which is 64, multiplied by 6. And right away I see that a 3 will go into the denominator twice, into the 6 twice. So that'll give us a 128 in the denominator. And the 3 will go into the numerator 15 times. And that is going to give us negative 15 over 128 multiplied by x cubed. 4 non-zero terms, we're good to go. There is the power series expansion for that function, for f. Now let's go ahead and let's just notice that the interval of convergence here is given for a binomial series. They're always given to us. We can't compute them with the ratio test like we normally would like to. Now let's find the binomial expansion for g. So for g, the substitution of x squared in for x is all we need to do. When we look at the comparison here, we see that the only difference is that we have to change the x from an x squared, from an x into an x squared. So we're just going to substitute an x squared in everywhere we see an x. Okay, so that looks like this. Substituting x squared wherever we see an x. We'll go to 4 non-zero terms. And this is what our expansion looks like. Now we have to modify our interval of convergence. Our original interval of convergence looks like this. But we replaced x with x squared, so we have to do that here. And what we notice is that the left side of the inequality is always true. So our solutions are coming from the right-hand side. We can take the square root of both sides here. And the square root of the left side is absolute value of x. Square root of the right side is 1. So what we see is that our interval of convergence has changed. We are now going to include negative 1 as well as the right endpoint of 1. So that is our new interval of convergence.